Here are my pages from the two previous videos with solving for different parts of a right triangle. The first problem I did, I solved for x. I used tangent because I had the opposite and the adjacent side, and tangent uses opposite over adjacent. The second video, I had the same triangle, but I was looking for the other angle. What I did is I went ahead with tangent again. This time, the opposite side was the 4, and the adjacent side was the 3. So I had tangent of y equals opposite over adjacent. And on the third problem I did, this time instead of looking for an angle, I was looking for the length of the hypotenuse. For this, I used the Pythagorean theorem, and I found that the hypotenuse was 5. I want to tie it all together in this last video with this same problem. I have a right triangle right here, and I want to solve the right triangle. Now, solve the right triangle, or solve a triangle, means we want to find the lengths and the measures of the angles of all the missing parts. So find the measures of all the missing pieces. I'm going to label my triangle with angles A, B, C. I'm going to have the right angle BC, so where the lines meet the vertices of the right triangle, I have a vertex of A, I have vertex of B, I have a vertex of C. So we could talk about angle A, angle B, and angle C. In keeping with the way triangles are traditionally labeled, I have a capital A for an angle. Across from capital A, that side is going to be little a. So little a equals 4. Across from capital B is side of 3. Little b, I will write a script b because if I write a print, it's going to look like a 6. Little b is 3. Now little c is across from capital C, and it's really hard to distinguish between a capital C and a lowercase c, but that one's lowercase and this one's a capital C. And I want to find the missing parts of this triangle. As I look at it and I see what I'm missing, I'm thinking probably the first thing I'm going to do is I'm going to look for C, the hypotenuse, because that's going to be fairly straightforward. So I'm going to write find the hypotenuse. To find the hypotenuse, we'll use the Pythagorean theorem. It's going to be a squared plus b squared equals c squared. A is 4, so 4 squared plus b is 3. 3 squared equals c squared. 4 squared is 16. 3 squared is 9. I get 16 plus 9 equals c squared. 16 plus 9 is 25. 25 equals c squared. Do the square root to solve it for c. Square root of 25 is 5. So I have found that C, the side, has a length of 5. Something I like to kind of do if I'm solving a triangle is where I'm going to show my work. I'm going to come over here and write the 6 parts. There's 6 parts here. You have 3 angles and you have 3 sides. Capital A is angle A. I'm going to put a blank. little a, I'm going to put on the same line as the capital A, and I'll put a blank. Capital B is angle B, and I'll put a blank. Lowercase b is side B, put a blank. Capital C is angle C, I'll put a blank. Lowercase c is side C, and I'll put a blank. And what I will usually do is the stuff they started me off with, I'm going to put in my blue ink. So side B had a length of 3. Side A had a length of 4. What else do I know? What else did they give me? They gave me the right angle. Angle C is 90 degrees. So I want to find the 3 missing blanks if I'm solving a right triangle. Lowercase c, we have found that with the Pythagorean theorem. I'm going to write that in red because it's something that I found with my calculations. So lowercase c was 5. Now I need to find angle A and angle B. You decide which one you're going to look for first. I'm going to look for angle A. You could go for angle B. You have a lot of choices here. As I look at angle A, I'm thinking, I have the 3 side lengths. I could use any trig function I want for angle A because I've already found the hypotenuse. As a rule of thumb, you probably want to use a trig function that uses the sides you were given. And you don't have to, but generally that's a good practice. I'm seeing that they gave me A, which is 4, and B, which is 3. A is opposite from angle A. I'm going to write that in pencil because I might erase that when I go after angle B, because remember the opposite and the adjacent will swap. So the A is opposite from A, B is adjacent to angle A. What trig function uses opposite and adjacent? Well, let me write out SOHCAHTOA. Some old hippie caught another hippie tripping on acid. That works for me. Okay. Now, I'm going to split this into 3 little parts there. And tangent is opposite and adjacent. So angle A, I'll write the tangent. I'll use A to represent the measure of that angle. The tangent of A equals 4 over 3. Now to solve it for the angle measure, you have to use inverse tangent. Inverse tangent of 4/3 equals angle A. I'm going to type that into my calculator. My calculator is in degrees, so I'm good there. Second tangent to do inverse tangent, and the ratio was 4 divided by 3, close parentheses, press equals, 53.130. This time I'll write it to 3 decimal places, although I'll probably go ahead and round it to 1 decimal place. So A is 53.1 degrees. On my little chart here where I'm writing all the information I'm finding, in the blank for A, 53.1 degrees. Now, it's a good idea to try to just use the measures they started with, the measures they gave you, to start the problem with. But we don't always do that. As I look at what I have so far, I'm looking at those angles, and I know there are 180 degrees in every triangle. I could use that little fact to get angle B a lot quicker than I can get it by using a trig function. So I think I'm going to use that to find B. I'm going to write this part right here on the paper. Find the measure of angle B. I could use a trig function, but I could also say, wait a minute, 180 degrees minus the right angle minus 53.1 degrees, angle A, will get me angle B. Let's type that in the calculator. 180 minus 90 minus 53.1 equals 36.9. So that's 36.9 degrees. So the measure of angle B is 36.9 degrees. My little angle mark there is written a little sloppy. I've also noticed some people might write it like this for the measure of angle B. The angle symbol with a little arc through it. Well, on my paper, let's go ahead and fill this in. Angle B is 36.9 degrees. And if you look back at the other three problems we've worked, they're all the same. Here's my first one where I used tangent to find x, which is actually angle B on this one. And then I used tangent to find angle y. Nothing is different there from what I did right here. That's angle A on this picture. And then I used the Pythagorean theorem to find the hypotenuse. So here's a problem where I've tied it all in together, and I hope that helps you to understand how we can tie some of this together to solve a triangle.